These are the notes for the sequences series. This is lectures. These are going to be really abbreviated, and it's only going to be condensed into one lecture right now so that we can cover enough stuff for the EOC. So here we go. So first thing, let's define a sequence. A sequence is a list of numbers where one term is related to the previous terms. Here's an example of a general sequence. Would be the numbers 1, 3, 6, 10, and 15. And we can see how these are related. Let's take a look. And to get from 1 to 3, I added 2. So I got 1 plus 2 equals 3. So we could see how the 3 relates to the previous term, which is 1. Now let's take a look at the next term in the sequence, 6. Well, 6 is the 3 plus 3. Let's take a look at how we get to 10. Well, 10 is the previous term, 6 plus 4. Let's get to the next term, which is 15. Well, 15 is 10 plus 5. So if we take a close look here, what we have is we're using the previous term, and we're adding to that the term number. So first let's figure out what these terms are. So you can see how we write that is here is something we could write A1. What that simply means is that's the first term. I have 1, 2, 3, 4, 5 terms in this sequence, and the first term, which is 1, and how I designate that, I can say A1 is equal to term 1. In this case, I can say A1 would be equal to 1. Okay, for the fifth term, I would have A5. This 5 just means the fifth term is equal to 15. So what we can see is that what I'm doing is I'm taking the previous term, which is in this case 1, and I'm adding whatever the term number is. Here the term number is 2, so that would be 1 plus 2. Over here I have the previous term, which is A3, and I'm adding to that the term number, which is 3, because that's the third term. So I can come up with this general little formula. I can say A1 is equal to 1, and then any term in the sequence would be equal to the previous term plus the term number. So I can find the sixth term, which would be equal to the first term, the previous term, plus the term number. So in this case, A6. Well, A6, here's 5 terms, so it would be the previous term here, 15, plus the term number. So for the sixth term, that'd be 6. I get 21. So that's just kind of a general sequence, and you can see that the numbers are related. The next thing is an arithmetic sequence. Now this is a specific type of sequence, and what we do is we add the same number to the previous term to get the next term. So say for example, here I have 1, and then I go to a negative 2, so I add to the 1, I add a negative 3. So let's add a negative 3 to negative 2, I get a negative 5. Add a negative 3 again, I get a negative 8. And that can keep going on and on and on, but that's an arithmetic sequence in which each term I'm adding a negative 3 to the previous term. And we call that negative 3 in this case. The negative 3 is a common difference. That's the difference between the terms. Next is a geometric. And a geometric is a special type of sequence where to get the next term I multiply by a certain number. And that number would be called the common ratio, R. That's how we call it. So for this example, I have 1, and if I take 1 times a negative 2, I get a negative 2. All right, let's take a negative 2 times a negative 2, I get a negative 4. Times a negative 2 is a negative 8. Negative 8 times negative 2 is 16. So this would be an example of a geometric sequence, and in this case, of course, R would be equal to a negative 2. So that gives us an overview of just what a general sequence is, what an arithmetic sequence is, and what a geometric sequence is, and we should be able to identify those. The next topic I want to cover is how do you find a certain term in a sequence? So let's say I wanted to find the 10th term or the 11th term or the second term. I have two formulas that I can use. One is an explicit formula. And that will allow me to calculate any term in the sequence without listing the whole sequence out. An example of an explicit formula would be something like this, where it says find the 10th term, and it gives me the formula a to the n is equal to n plus 7. So this says the n here, that just says the term number, so if I'm going to find the 10th term, I would put a to 10. And then what I have to do is fill 10 in for the n, so that would be 10 plus 7. So the 10th term in that particular sequence is going to be equal to 17. So that would be an example of an explicit formula. Now, an example of a recursive formula is that tells us how to get to the next term in the sequence given that they give me the previous term. And to do that, I'm going to have to starting point, and then I'm going to list all the terms out until I get to the term that I want. So this is a useful formula in that it lets me know how I go from one number to the next. Now notice the previous one didn't. It just says this is how I get to a certain term. Of course that one's pretty easy. It's n plus 7. So you could really tell how to get to the next term, but some of them are more complicated. But it does allow me to calculate any term in the sequence. The advantage of the recursive formula is I know what I'm doing to get the next term. That's listed in the formula. And what I would need is I have to have a starting point for that formula, A1, so it may give me A1. It may say A1 is equal to. And then it's going to tell me how I can get to the next term. So then if it's like I add to get to the next term, it would say something like, okay, A to the n, that means the next term in the sequence is equal to the previous term. That would be n minus 1, say plus 4. So to get to the next term in the sequence, I would just add 4, but I have to have a starting point. So here's an example. Find the 6th term using the recursive formula, and here it gives me a formula. It says, okay, the first term is 10, and let's say to get to the nth term, I take the previous term, that would be a to the n minus 1 plus 2. So this is how I would find the 6th term. I know the first term is 10. Now to get the second term, I would add 2 to the previous term. So that would be 10 plus 2 is 12. Then to get the next term, I add 2 again. Get 14. Then I get 16. Then I get 18. Then I get 20. And to find the 6th term, I would have to list all the terms out. So when I get there, that would be 20. And that's how I'd have to use a recursive formula. So we can see the disadvantage of a recursive formula is I need to list all the terms out, and I need to have a starting point to start with. So that's a recursive formula. Next topic is let's look specifically at an arithmetic sequence. Remember, this is a sequence in which some number is added to the previous term to get the next term. And it's always the same amount that I'm adding to the previous term. And that amount is called the common difference. And how I state the common difference in a formula is I use the letter D. So here would be an example is I have the sequence 5, 10, 15, and 20. What you can see is I add 5 to the previous term to get the next term. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. So in this one, D is equal to 5. The explicit formula for an arithmetic sequence is a to the n is equal to the first term plus d times n minus 1. So that's the formula I'm going to use to find an explicit formula for any arithmetic sequence. And remember, an explicit formula allows me to calculate any term in the sequence without listing it all out. So here's an example. Here I have a list of numbers. And what I can find is I'm going to use this explicit formula, and I'm going to come up with the explicit formula of this particular sequence. So A1, that's my first term, that's a negative 1. The common difference is a negative 4. To get from one term to the other, I subtract 4. So plugging those numbers into my explicit formula here, I get a to the n is equal to A1, the first term. In this case, it's a negative 1, so there's the negative 1, plus, right, there's my plus, d. Well, in this case, d is a negative 4, so it's a negative 4 times n minus 1. There's n minus 1. So Taking this negative 4 and multiplying it times the n, I get a negative 4n. Negative 4 times the negative 1 is a plus 4. So simplifying that formula, I would get negative 4n plus negative 1 times 4 is 3. So that's the explicit formula for this particular sequence that I have here. Then if I wanted to find some term in that sequence, let's say the problem said, okay, find the 52nd term. Well, what I would do is would need, remember, so that here's my explicit formula for that particular sequence. I would plug 52 in for n. So this is n, 52, down below. It's a subscript, so it's saying the 52nd term is equal to a negative 4 times n. I'm looking for the 52nd term, so n is 52 plus 3, which would evaluate to negative 205. Okay, for that particular list of numbers, which I have, negative 1, negative 5, negative 9, negative 13, here's the recursive formula. And remember the recursive formula, I have to have some starting point, and then I have to say, okay, to get to the next term in the sequence, an, I have the previous term, a to the n minus 1, plus some common difference, d. So for this particular sequence that I already said, d is equal to a negative 4, then what I'm going to do is I'm going to take a1, okay, in this case it's a negative 1, so I'm listing it, and an, so what I'm saying is the next term in the sequence is equal to the previous term, so that's a to the n minus 1, plus my common difference, which is negative 4 minus 4. So there's my recursive formula for this particular sequence. And now if I needed to use the recursive formula to find a particular term number, and I'm not going to do 52 terms, but I'm going to get the 6 terms, so I need to list them all out. So here's what I'd have to do. The starting point, I'd say a1 is a negative 1. Okay, then a2, what would happen is I'd have to subtract 4 from that. Okay, so that's a negative 5. a3, I'd have to subtract 4 from that. That's a negative 9. a4, I have to subtract 4 from that. That's a negative 13. a5, I have to subtract 4 from that, so that's a negative 17. And a6, I'd have to subtract 4 from that. That's a negative 21. So I found out that a6 is equal to 21. But you see, I had to list all the terms out to get that, so that's the disadvantage of a recursive formula. Okay, now let's move on to geometric sequences. Now, geometric is a situation where to get the next term, we need to multiply the previous term by some common ratio r. An example would be this sequence here, 2, 6, 18, 54. As you can see, to get the next term, I've multiplied by 3. Then I multiply the 6 by 3, then the 18 by 3. So here, the common ratio r is going to be equal to 3. Now, it could be a fraction, and the numbers would get less. It could be negative, and then it'd switch back and forth. An explicit formula for a geometric series, here's the formula. It's a to the n, that gives me whatever term in the sequence I want, is equal to the first term times r, then to the power of the n minus 1. So an example of that is you can see that what I have here is I have 2 to negative 10. That'd be a common ratio of negative 5. If I take each term and multiply it by negative 5, I get the next term. So what I have is I would have r is equal to negative 5. So we're going to use this formula. It would be a to the n is equal to the a1, which is the first term, times r to the n minus 1. So a to the n would be equal to the first term here's 2 times r is a negative 5 to the n minus 1. And this would be my explicit formula for that particular problem. And then if I had to calculate some term in the sequence, like the eighth term, well, I just plug 8 into this formula for n, so I have the eighth term, 8 is equal to 2 times a negative 5. Let's plug 8 in for n minus 1, so 8 minus 1, that's 7. So 2 times a negative 5 to the 7th would be equal to a negative 156,250. So that's using my explicit formula. The recursive formula for a geometric series is I'd have to give the first term. Remember, recursive, I have to state some starting point. And then to get the next term in the sequence, in this case it's a to the n, it's the previous term, a to the n minus 1, times the common ratio. So in the previous example, where I had 2, negative 10, 50, negative 250, the recursive formula would be, I state the first term, a1 is equal to 2. That's the first part of my formula. And then I would say to get to the next term, I take a negative 5 times the previous term. So that would be an is equal to negative 5 times a to the n minus 1. Of course, I could put the negative 5 behind it too. It really doesn't matter, but it's the same thing. Okay, let's move on to a series. Now, a series is different from a sequence in that I take the numbers in a sequence and I simply add them together and I come up with a value. That value is the sum. And, if I just had a list of numbers, like say I had this list, 1, 3, 5, 7, the series would be I'd add those all together. That'd be 1 plus 3 is 4, that'd be 9, that'd be 16. So the sum of that series would be equal to 16. Now, one of the ways that we show that we want the sum of a series is this summation notation. And we use the Greek letter sigma, so it's also called sigma notation. And so sigma is looks like a W kind of turned on its side, but it's pointy like that. And actually these are flat. So I guess that would be a better view of it. And this is how we use the sigma notation. It's going to have some value at the bottom, which says n is equal to 1, and that's where we start. That would be the value of n that we use at the start. And we're going to add all the terms together until we get to term n equal to 4. And here would be the formula that I'm going to use for each term. So say, for example, this is what I would do. It says the formula is n plus 1 squared. And this means that I want to start at term 1 and add all the terms together through term 4. So what I would do is I'd put a 1 in here. That would be term 1, 1 plus 1 squared. And I made a mistake here. So that'd be 2 squared. Actually, I didn't. It's 2 squared. Then I would go to n equal to 2. So that would be 2 plus 1 squared is 3 squared. Then I would go n equal to 3. It would be increasing by 1. So that would be n is equal to 3. 3 plus 1 squared. That would be 4 squared. And actually, somehow I got off. N is equal to 3. 3 plus 1 squared. 3 plus 1 is 4, so that'd be 4 squared. And then lastly, n is equal to 4. That's my stopping point. So if I plug 4 into this, 4 plus 1, or plus 1 squared, that would be my last term. So I would have 2 squared plus 3 squared plus so on and so forth. And 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So I would add those all together and I would get 54. And so that would be the summation notation and how to use it to add a list of numbers together, a sequence together to form a series, whether it be geometric or arithmetic. Now, sometimes there's a quicker way that we could use. So instead of adding all the terms together, that's actually what I do with a series, but maybe I don't have to list them out. And I don't have to. There's a formula for both arithmetic series and geometric series to get the sum of all the terms without actually listing them out. And here's that formula. Okay, so the formula is find the sum of an arithmetic series, S of n. I take the term number, n, of all the terms that I want to add together, in parentheses, a1 plus an all over 2. So here's an example how that would work given the summation notation here. So notice I'm starting with n equal to 1, I'm going to n equal 20, and here is my arithmetic formula. So what we need to do is we need to find the first term, because look, the formula says a1, so let's find a1. So we're going to put 1 in for n. That'd be 3 times 1 plus 7. That would be 3 plus 7 is 10. So A1 is equal to 10. The formula also uses AN. And in this case, the n is 20. So we would have plugging 20 into 3 times 20 plus 7. 3 times 20 plus 7, I get 67. So I found A1, I found AN. So then what I need to do is to use this formula. I would take A1 plus AN, divide by 2, and take it times n. Remember, n in this case is how many terms I'm going to have. It'd be this number 20. So 20 times 10 plus 67 over 2. That's 20 times 77 over 2. 10 times 77 is 770. So notice that I was able to get the sum of this arithmetic series without actually adding all 20 terms together by using this formula. Okay, same thing for a geometric series. Here's the formula to find the sum of any geometric series. And it says take the first term and take it in parentheses times 1 minus the common ratio to the nth power all over 1 minus r. So here's an example how that would work. Here I have an example. It says find the sum. I'm starting at n equal to 1, and I'm going to n equal 10. And here's my geometric series formula. So it's 4 times 3 to the n minus 1. Okay, so the first thing, let's find A1, because we're going to need that for this formula. Well, that would be plugging 1 into n. So let's plug 1 into this n. 4 times 3 to the 1 minus 1. That would be 4 times 3 to the 0 is equal to 4. So my first term, A1, is 4. My common ratio is this 3, and so let's plug the numbers in. So I've got S sub n, the sum of the geometric series is equal to 4, times 1 minus the common ratio. 1 minus the common ratio is 3 to the n. In this case, we want 10 terms, all over 1 minus the common ratio, which is 3. So if I would calculate that out, I get the value of 118,096. And that's how I can use this formula instead of actually listing all 10 terms out and then adding them together.